This is my response to question 1, champion of PLTW. STEM education stands for science, technology, engineering, and mathematics, which all play a role in the biomedical PLTW classroom. We use science, obviously, is the main portion of the curriculum. And to teach science, we use technology, using computers every day, using lab equipment. We use engineering principles to see how science and engineering are related. And we also use math to do statistical analysis, when we use microscopes, when we measure DNA, things like that. So we use all components of STEM in the PLTW classroom each day. Part 2, describe the 3-phase model of professional development with PLTW. There are 3 phases of professional development with PLTW. The first phase is the readiness phase of professional development, and that is when you go online and you take a pre-assessment before you go to your training to make sure that you have the necessary background knowledge needed to complete the core training. Phase 2 is the core training, where you go to an affiliated university with PLTW and you get to join other professionals in learning about the curriculum and how to best teach it in your classroom. And the phase 3 of the professional development is the ongoing training, where you can go to online forums and discuss teaching practices, assessments, conferences with colleagues all across the nation, as well as PLTW offers annual conferences each year to their teachers. So those are the 3 phases of professional development. And lastly, one situation where I have been able to encourage people to take action through Project Lead the Way is when professionals come to our site. My high school is one of the only high schools in Northern California that has a complete biomedical course program, including the capstone course. And we have a lot of neighboring districts and schools come to check out our program. Administrators come, teachers come, just to see what is needed to set up a PLTW classroom and actually run the program, what equipment is needed, what type of teaching goes on in the classroom, what are the students engaged in and doing. And a lot of people have come to check out my classroom, and I've encouraged them to take action through PLTW, because if I did not get to teach in a classroom like this, with the curriculum set up the way it is, I don't know if I would be having as much fun teaching as I am. So I've really encouraged people to take action and start PLTW programs at their school. This is my response to question 2, describe PLTW's activity, project, and problem-based learning framework. Both teachers and students take a very active role in the PLTW classroom. I find that there is very little time where students are just sitting in their desks taking notes, listening to the teacher direct. And I find that there is a lot of time where students are actually engaged in activities, talking with the teacher and moving around the classroom, doing projects and using lab equipment and computers. So I love that the classroom is very active and that students and teachers are moving and engaged and communicating with each other. One experience that I've had using activities, projects, and problems to scaffold student learning is when students walk in to the PBS classroom. The first unit is about human body systems. And I love the approach that PLTW takes to learning about each of the different body systems, because it's not a direct teaching approach where I give notes and the students take notes and memorize them. It's an active, engaged, project-based learning style. So one of the things students get to do in the first unit in Principles of Biomedical Science is create a life-size poster as a class of all the human body systems, or most of the human body systems, and all the organs in each system, and what each of those organs look like and what they do. So what happens is each group gets to be assigned a body system with select organs from that system, And what they do is they research that body system, how it functions in the body as a whole, and what each organ is responsible for. And they make life-size cutouts of each organ, and then they get to put all that info into a PowerPoint and present it to the class. And students get to then take notes and learn about each of the body systems as each group presents. And it's just a more engaging type of learning than straight teacher-led instruction. So students get to look things up, create models of them, and then they get to present their work to the class. So they actually get to review the information that they've learned 3 times. And I think that that is more engaging. Students remember the material more often, and they love to learn and hear from their peers. One situation that I have done in the PBS curriculum that is different than traditional teaching practices is that I have created a gallery walk for all of the career journals in the PBS curriculum. I found that we don't have time to complete all of the curriculum in one semester because we're on block scheduling. So what I've done is I've created a project out of the career journals where each student is assigned one of the careers that is encountered throughout the curriculum. And what they do is research everything about that career like you would in a career journal, and then present it in the form of a poster, a puppet show, a video, however they choose to present. And we have a gallery walk where students get to take notes on all of the presentations set up around the room. And they also get to present the work that they've done. And they learn about all the careers in the PBS curriculum in one day. So that allows me to fit all the curriculum into the semester. And students love the gallery walk. They tell me each time how they learned about new careers that they never knew existed, and they liked how different students presented the information, so that's been a real success. All right, this is question 3. Describe how your experience working with adult learners. And I believe that adult learners and student learners can learn in similar ways, but they can also be very different learners because adults bring a wealth of background knowledge, career experience, and education experience to the table and to the classroom. So that is great. I love that each time I go to core training, I meet different professionals from all different backgrounds that are now in education, and everyone brings different background knowledge to the classroom and to the table. So that's been a great experience. One situation where I have found that it has been difficult to work with adults was actually at one of the core trainings. It was the first one I went to for Principles of Biomedical Science, and we had to do the grant proposal, and everyone had a different thought that they believed was really important to include in our proposal. Our proposal was working with obese children that were at risk for type 2 diabetes and creating after-school programs to help these children. We were specifically focusing on Alabama, which was the state with the most children at risk at the time. And everyone had a different aspect that they thought that the grant should be focused on: exercise or nutrition or family education. And finally, after a good hour of discussion, we found a way to incorporate bringing everyone's specific concerns and knowledge into the grant by just making a little bit more general idea to the grant so that we could include everyone's specific background knowledge. And it turned out wonderful because everyone brought such unique experience and knowledge to the table. One way I believe that you can determine if success has been achieved when working with adults is if adults are willing to try new things and maybe step out of their comfort zone. I know as you grow older and get more experience, it's easy to continue to do things in the manner that works for you. And I think that one way you can measure success when working with adults is if they're willing to try new ideas or maybe teach in a new way, try a new modality of teaching. And when they are willing to grow and change and step out of their comfort zone and try new things, they will grow as an educator, they will grow as a professional, and that's how I think success can be determined when working with adults. This is my response to question 4. What course are you applying to be a master teacher for? I am applying to be a teacher for the Principles of Biomedical Science course, the first of the 4 courses in the biomedical pathway for PLTW. And what differentiates PBS from other courses in the biomedical pathway is that PBS kind of lays the foundation, it lays the groundwork for the entire program. What we do in PBS is we study pressing issues facing healthcare today, such as heart attack, diabetes, sickle cell, hypercholesterolemia. And what each of the other courses in the biomedical pathway focuses on is not as broad. It's more focused. So, for example, the human body systems and how they function together, or what medical interventions are available now and what are up and coming for the future. So I enjoy teaching PBS because it lays that groundwork for the students. And I believe it is important in preparing them for the global economy because there are many careers in healthcare that will be facing these issues that we discuss. And healthcare is an up-and-coming field. Many of our students want to go into healthcare. With the baby boomer generation and the life expectancy getting longer in our nation, the issues discussed in PBS will lay a foundation for our students to go out and get jobs in the near future in our economy. How we incorporate math, science, and technology into the classroom is simple. Obviously, we teach science daily, and we use math and technology to do that. Technology is used daily in the classrooms. We use computers. We use Inspiration software to make flowcharts, concept maps. We use Vernier software to measure blood pressure, pulse, EKGs. We use gel electrophoresis chambers, microscopes. So we're constantly using technology. We also use math to measure the size of cells under a microscope, or the size of a virus compared to the size of a bacteria, compared to the size of a eukaryotic cell. We use math to determine the length of all the DNA inside one cell. If we unraveled it and laid it end to end, how long would it be? So we use math consistently throughout the course to teach the science concepts. This is my response to question 5, teaching a lesson from the curriculum. The lesson I chose is from the Principles of Biomedical Science curriculum, PBS, and the lesson is from Unit 1. It is lesson 1.1.5, and the objective is to make a concept map showing the interconnections between 2 of the human body systems. So the 2 systems that we are going to compare today are the cardiovascular system and the respiratory system. And to give you a visual on where those systems are, we have our mannequin here. So in the mannequin, the lungs are located here in the thoracic cavity, and the heart is in the middle, slightly to the left, in between the lungs. So we are going to compare how the respiratory system and the cardiovascular system are related today. So to get us started, let's brainstorm a little bit about the components of each system. So take a minute and discuss with the people next to you what are some of the components of the cardiovascular system, and then we'll share our answers out loud. Some of the responses that students may come up with are the heart, the vessels, the arteries, and the veins. Great. Now let's take a minute and discuss some of the components of the respiratory system. So take a minute and discuss those. When students are done discussing, some of the things they may come up with are the lungs, gas exchange involving oxygen and carbon dioxide. Now let's see how we can put these components into a concept map and show how they're interconnected. So I have started our concept map for us. As we read earlier in the objective, we are comparing two human body systems. So that is our main idea, right in here in the main bubble. The systems that we've chosen to compare today are the cardiovascular and respiratory systems. So respiratory and cardiovascular bubbles are coming off of each one. Now, we need to add in some of the components of each of the systems to our map and show how these systems are related. So let me give you one example of how the systems might be related. As we mentioned earlier, the respiratory system contains the lungs. Okay? And the lungs take in oxygen. Right? Pretty basic concept. Now let's look at the cardiovascular system. We mentioned earlier the cardiovascular system contains the heart. Okay? And one way that we could show how the systems are interrelated is we could show that the heart pumps oxygen, which was taken in by the lungs, to the body. We'll just add another bubble on here. So, one way the two systems are related, the heart pumps oxygen to the body. Now let's have each of you work on your own and add to our concept map other ways in which the two systems are related using the information that we brainstormed earlier.